Hi everyone, welcome back to my channel. Today we will be learning about formation of NaCl by electron dot structure. So this is a part of chapter 3, that is metals and nonmetals, formation of ionic compounds. First we will be learning about NaCl, formation of NaCl. So NaCl is a ionic compound which is formed by two atoms, sodium and chlorine, and it is mainly between two ions, that is sodium cation and chloride anion. So first let us understand the electronic configuration of sodium and distribution of electrons in the different shell. So sodium has an atomic number of 11, atomic number 11, and if I distribute the electrons in K, L and M shell, so according to 2n square rule, K shell can accommodate maximum of 2 electrons, L shell can accommodate 8 electrons, and 2 plus 8 is 10, but the atomic number is 11. So one more electron gets accommodated in M shell. Now here the problem is that sodium wants to get rid of this one electron because it is not stable, because if it donates this one electron, it will gain stability by attaining octet configuration, that is 8 electrons in its outer orbit. So hence sodium is electropositive, because we know metals are always electropositive. They have a tendency to donate electrons. So sodium would donate one of its electron, that is an M shell, to form Na plus an electron. So here, if I have to specify the electronic configuration or distribution of electrons, so I will write 2, 8, 1. And since it has donated one electron and has gained a positive charge, because always remember students, elements, they gain, they lose one electron or n number of electrons and they get a plus charge on them. Whereas if a non-metal, if we're talking about non-metal, they have a tendency to accept electrons and they become, or they gain a negative charge, and they're called as anion. So now this is sodium cation, so 2 comma 8. So this means that one electron of sodium has been donated to some other atom which is ready to accept. Okay, so now next if I have to write about the next atom, that is chlorine. So chlorine is having electronic configuration 17, and if I distribute its electrons in K, L and M shell, so as I already said, according to 2n square rule, 2 electrons maximum in K shell, 8, 2 plus 8 is 10, and the remaining 7. So now here chlorine wants to gain one electron, because if you look at the outermost orbit, it is unstable because there are only 7 electrons. It is deficient by one electron, so it needs that one electron which is being readily being donated by sodium. Okay, so if I have to write on for chlorine, so chlorine plus one electron, okay, because it is accepting one electron. So always remember students, after the arrow mark, if there's any electron, it means that it has donated, and before the arrow mark, if there are any electrons, it means that it has accepted. Okay, so chlorine will accept one electron to become Cl minus. So now if I have to write the electron distribution, it will be 2 comma 8 comma 7, and here 2, 8 and 8. So this is how the the first part of writing Na plus and Cl minus happens. So now we're moving ahead with the last part of the formation of NaCl. So sodium will donate one electron. So I will just put a dot. Similarly, plus chlorine. Now how many electrons are there for chlorine? There are 7, 2, 8, 7. So 1, 2, 3, 4, 5, 6 and 7. Okay, so now what's going to happen is this one electron of sodium will be given to chlorine. So how I write it finally is, because sodium has donated one electron, so it gets a plus charge. And then chlorine will now be getting 8 electrons because one is being donated by sodium. And then I write a negative charge and I close it with the brackets. So this is how we write the formation of NaCl. So usually in exam, it's a mandatory question. So they can ask any ionic compounds. It can be like examples would be like NaCl, MgO, MgCl2, Na2O. Okay, so there are so many ionic compounds. So for all of them, you can write on the same method, just that we should be knowing the electronic configuration and distribution of electrons in K, L, M, and N shell respectively. Okay, thank you very much.